Hello everyone, and I welcome you all in this learning video which is on calculus. So whenever the word calculus strikes in our mind, so the very two things that comes to our mind is, what is it? One is the differential calculus or derivative calculus or the integral calculus. Derivative or differential. Okay, so this differential calculus you have already seen in the previous module. We are going to learn on integral calculus, and whenever we talk about the integral calculus, then again there are two things which we encountered with. One is the indefinite integral or indefinite integration, and the second one is definite integration. Second one is definite integral. Okay, so on a very quantitative manner, you can say that indefinite integral is nothing but the integral which gives us a function, whereas definite integral is nothing but an integral which gives you a number. Okay, and it represents the area under the curve. So that is what we are going to learn. So let us start with the indefinite, and then we'll see a transition from indefinite to definite, and followed by the examples and some things like how to solve problems by substitution, by integration by parts, by using the help of properties, and so on. So that is what we are going to learn in this. Okay, so before that, let me tell you some wonderful applications of double integral. So one application I have already told you, that represents the area under the curve. Another thing is, it is used to find out the area under the curve and also the volume and surface area of several solid shapes that we shall see at the end of this module. Okay, and this module in particular will help you in competitive exams like GATE, then say IES, then NDA, CDS. So if you opt for mathematics in NDA or CDS, you may be having problems on integration. Okay, so now let us start with some elementary integration. So the elementary integrations we will start with. If you want, you can go through the list of elementary integrals that we have, that I have already uploaded in the module. Okay, so what is integration? So let us recollect some of the simple integration, elementary one. What is integration of x to the power n dx? Integration of x to the power n dx is x to the power n plus 1 upon n plus 1 plus c, right? Second thing, what is integration of 1 by x dx? So integration of 1 by x dx is log x plus c. Let us take very important function which is a very favorite of mine, is integration of exponentiation function, that is integration of e to the power x dx is e to the power x plus c. Now my question is, what is the c? You may be saying that c is constant of integration. Okay, that's correct. So the very next question is, why we write this constant of integration? So some of you may know about it, why we write constant of integration, some may not. Okay, so as you know that integration and derivatives are opposites of each other, that's why integration is also called as antiderivative. Suppose you have a function f of x square plus 7. Suppose this is the function you have. Then what is its derivative? Its derivative is 2x plus 0. So 2x its derivative. Now as you know, integration is antiderivative, meaning thereby if I apply integration on it, I must get this Okay, so come on, integrate. So when I integrate this, integration derivative get cancelled. So I will be getting f of x is equal to 2 into x square by 2. But according to the rule, what should we get? We should get x square plus 7. So just because to manage this 7, we write constant of integration as c. Okay, so that is why we write constant of integration, because when we take the derivative, this constant terms will be vanishes, and when we take the integration of the same, we should get the same thing, but we are not getting the same thing. We are getting x square, but we should get x square plus 7. So just to get x square plus 7, so we just write constant of integration c. Okay, now let us take some take some of the very simple integration. So before that, taking that simple integration, let me tell you one result, which is integration of f dash of x upon f of x dx is equal to, what is it? Log of mod of f of x plus c, right? Now let us solve some problems. So evaluate, so let us take problem number 1. Evaluate integration of e to the power log of x dx. So suppose we have to find out the value of this, okay, and there would be some 3-4 options will be given to you, like x plus c, x square by 2 plus c, log x plus c, log of e to the power x plus c. Suppose these are the 4 options given to you. Okay, now you just need to remember that exponentiation and logarithm are opposites of each other, or they cancels each other. Okay, so what is this? So remember the formula, e to the power log of something is something. Okay, e to the power log of Shah Rukh Khan is equal to Shah Rukh Khan. Okay, e to the power log of Sunny Deol is equal to Sunny Deol. Okay, so you remember this. So it is like that only, e to the power log of x. So what is it? This is same as I is equal to integration of e to the power log x dx is nothing but integration of x dx. So just to make it complicated, such things are given in the competitive examinations. So this get cancelled. What is integration of this? X squared by 2 plus c. So what is the correct answer? B. Okay. Now you may take some different problems. So let me take another problems here. Say number 2. So this is the problem. Let me take the problem. Evaluate integration of dx upon x into log x. So if you want to evaluate this, what you can do is, let I is equal to, you can write let I is equal to, now may I write this as 1 by x, so I can write it as 1 by x dx upon log x. So this is of the form f dash of x upon f of x. F of x is log x, and what is its integration? 1 by x dx. Okay, so applying this formula, you will be getting log of f of x. What is f of x? Log of x plus c. Okay, simple. Now you can take one more problem, like these are very elementary things, and these elementary things these days not so much complicated things are asked in the competitive examination. Very small little things, but the basics should be good. Okay, so on basics also it is asked most of the time. So let us take another example. Integration of log x upon x dx. So suppose this is the problem you have to solve. Okay, so how can we solve this problem? Let us make it more interesting. Integration 2 to 3. Evaluate this integral. So you can do like put log x equal to t, 1 by x dx equal to dt. Okay, that is means you have to make substitution that we shall take in the upcoming video lectures. Now, just because of this, now earlier there will no limits were given to us. Now it's a given limit. Okay, so before knowing what is definite integral, if we solve the problems of definite integral, that should not be done. Okay, so the very next video lecture will be on definite integration. So to solve this, we must learn definite integral in the next video, and to solve this problem, we'll go for the method of substitution. A very next in the video lecture we'll see. Okay, so I hope this is making sense. Thank you for watching. Good day.